Hi, welcome to this Microsoft Certification Exam Prep session. My name is Christopher Harrison. I'm a senior content producer here at Microsoft Virtual Academy. You can find me on Twitter at @GeekTrainer. And today we're going to be taking a look at exam 70-483, which is the C# exam. And I do want to mention right up front that this particular exam is the entry point into many a certification path, including for web developers and for Windows Store developers. So definitely a great little entry point. Now, we do have the ubiquitous outline slide, which you can see right here. And what we're going to wind up covering is technical content, some exam tips, and technical content. So I'm really going to work to eliminate a lot of fluff from this. And so we are going to then touch on some complex concepts, some technologies that you might not be familiar with, and some sample questions. Now, there's two big things that we won't touch on. One which is listed on this slide, which is things like console write line. I'm going to assume that you know C#, which actually leads me perfectly into my next point. And the second thing that we're not going to cover, which is everything that you would need to know to take on the exam. That we're going to be here for about 50 minutes. Well, I guess I'm going to be here and you're going to be there. But it's going to be for somewhere in the ballpark of about 50 minutes. And there's no way that I could take you from knowing nothing about C# to being certified in 50 minutes. And if I could, honestly, the exam really wouldn't mean a whole heck of a lot. So my goal here really is to get into some of the different areas that maybe you're not overly familiar with, maybe you've only done once or twice, or you just haven't done in quite a while, that is going to be covered on the exam. So that's my goal here, and so that's what I want to dig on into. So the basic outline that we have is we're going to take a look at the 4 topic areas that are called out as part of the objective domain, which is manage program workflow, create use types, debug applications, implement security, and then finally, last but not least, implement data access. Now, if you're curious as to where I got that idea to go in and have that as the outline, where I got that from was the exam prep page, which you can notice on Microsoft Learning. So you'll notice that there's the little page, and in particular, if we scroll on down, you're going to notice that we've got a little skills measured section. And if you take a look right here at our manage program flow, create use types, debug applications, implement security, implement data access, those are the 4 that are listed right there. And if you want to find out more information about each of those topics, or to maybe dig a little bit deeper into some of the information, that's a great place to start. So just head on over to www.microsoft.com/learning, do a real quick search for that 70-483, and you'll be able to bring up that page that I just displayed there, that I'm now just trying to make go away as I go tapping around on my monitor. In the meantime, you're going to notice the basic roadmap that I've mentioned before, and this is the entry point into web applications, SharePoint applications, and Windows Store applications by utilizing C#. There's the exam guide, and again, I've already displayed the page, so I'm not going to worry about bringing that up. And then there is the exam outline, again, as I've already mentioned. All right, let's dig on into it. Let's take a look at working with our program flow. Now, by program flow, we don't mean if statements and while loops. What we really mean is, how is the application actually going to run? And when we're dealing with complex applications, when we're dealing with trying to improve performance, when we're dealing with Windows applications, threading becomes a very big concern. And .NET actually offers you a lot of different ways that you can do threading. And one way that you can do threading is by using the thread object. Now, the thread object, sort of as the name implies, is going to represent a thread. And so as a result, it's going to give us complete control over the thread, which is a good thing. But on the bad side is it's also going to give us complete control over the thread. And that's oftentimes a lot more power than we actually need. That a lot of times, and I would say pretty much all the time, what we need to have happen is this, is I've got some long-running operation. I know that this is going to take a few seconds. I don't want this to stop my program, so I just need that to run over here. And then once that's done, it can let me know once it's done, or if it's just going to complete on its own, that just let it complete on its own, but just have it do it over there. That just put it over there, it's going to do its thing, and that's all that I really care about. So you typically don't want to use a thread object directly for that. Now, if you do still want to get relatively low level, but don't want to use the full thread object, this is where the thread pool comes into play. That the CLR is actually going to manage a pool of threads for you, and it's going to be optimized based on the environment. The great advantage is this, is that if I create 5 thread objects, what I've instructed .NET to do, what I've instructed the CLR to do, is to create 5 separate threads. Well, maybe that's not optimal. Maybe we've only got 4 cores or even 2 cores at our disposal, and now we're trying to manage 5 separate threads here. That's not really a good place for me to be, but that's exactly what I told the CLR to do. By using the thread pool instead, I'm going to leave it up to the runtime to determine how many threads we actually need, and then it will go ahead and manage them appropriately for me. Now, if it turns out that I'm trying to do too much for the optimal number of threads, it'll automatically place any new requests in a queue. This is the preferred mechanism. You want to use the thread pool rather than using the thread object directly. Now, at an even higher level, we have tasks. And what a task is designed to do is it's designed to represent an asynchronous operation. An operation where it's going to run in the background and then come back to me with a result. So for example, if I'm calling off to a web server, I'm calling off to a database, and I know that that's going to take a few moments, I can put that off onto a separate thread. It's an asynchronous operation, and then it will get back to me with the result. Now, what you are going to notice is that it's going to reference what's known as an action delegate. The action delegate can have a return type, but no parameters. But it can, if you want, however, if you want to pass some information, have a state object that it's able to actually use. Now, what's great about a task object, there we go, there's my little code, is this, is down at the very bottom here. I've got a little method here that we've called doWork. And what you're going to notice on doWork is that we've got some operation that's going to take a little while. Now, what this operation is actually doing is sort of irrelevant, but it's just going to take a little while. Now, if I want to spin that off and I want to have that run all on its own, then what I can do is I can either new up a task manually, or better yet, I can use the task factory, which you see right here, and tell it, hey, look, I want to start a brand new task, and I want to point at that method. So you'll notice that there's my doWork, and there's my doWork right down here. So that's now going to be inside of a task. And if I just stop there and let the task run and do its thing, everything would all be hunky-dory peachy keen. Cool. But let's talk about things for a minute here. We're talking about an asynchronous operation. We're talking about something that might take a little while. And for one reason or another, maybe because the user becomes impatient, maybe because we have a timeout, maybe because we're going to close out the application, we may want to cancel this task. Now, canceling a task is possible, but it takes a little bit of legwork because the task needs to be aware of the fact that we want to cancel it. So if we go back and we take a look at the doWork method, which is going to be inside of that task, what you're going to notice here is that we're going to be looking for a token. More on that in just a moment. And in particular, we're looking for a little property right here that says, is cancellation requested? And so if it is, we're then going to exit out of the method by calling return. Now, what's this token? Well, you'll notice right up at the very top there that that's a cancellation token. Now, in order to set this up, what we need is we need a token source, which we're just going to new up right here, and then just get that token. And then what we can do is we can use that token down below to check the state. And here's a big key, is that when we want to cancel the operation, we simply call cancel on the token source. So you'll notice I did declare the token source up there. When we want to cancel the operation, we call cancel on the token source. When we want to detect that it's been canceled, then we go in and look at the token itself. And that'll give us the opportunity to cancel out that operation. Now, if we even want to go one step at a higher level, we have async and await. Now, async and await give you the simplest mechanism for setting up asynchronous development. Async and await are built on tasks. Now, the way that this is going to work is that we set up one method. It's going to be called or decorated with the async flag, and that's the one that's going to run on the separate thread. What await is going to do is it's going to tell the runtime, hey, look, I'm going to sit here and I'm going to wait until that's done. But here's the key, is that while I'm telling it, hey, look, I'm going to sit and wait till that's done, it's not going to block the thread. What I just told the runtime is, hey, look, I got to sit here and wait, but you go on ahead with whatever else it is that you've got going on, which would include the task that I've told it to run asynchronously, and then anything else that might be going on. So if this was a Windows app and somebody clicks on a button, that can still work. So I'm going to sit here and I'm going to wait until that's done, but everything else around me can still continue operation. So other threads are not blocked even though I use that await mechanism. Now, to take a real quick look at await, what you're going to notice is that I've got a basic little setup here where I'm going to use HTTP client. Now, in order for me to use await, I need to decorate the method with async. That's required. Then you're going to notice I'm going to set up my HTTP client. And then you're going to notice that I'm going to make a call to getString async. And that is convention in .NET that if you're going to create a method that supports asynchronous or await, that it end with the word async. And then what you're going to notice right here is that I'm going to just do some work. Here's the cool part, is that when I make that call, I can still keep doing things. So if I need to update the UI, if I need to do a couple of things, I can go ahead and just do that right now, because the asynchronous operation has already begun. So that's happening over here, and I'm doing some work. I do my work, and I do my work. And then once I get to a point where I go, okay, you know what, now I need that value, that is when I call await. And so you'll notice right here, there's my call to await. And what's going to happen is that's now going to wait until that method is complete. Again, other threads can keep working. It's going to wait right there. Once I get that result back, then we'll go ahead and move on to the next line. And then you can see that right down there at the very bottom. Okay. Now, what happens if I'm using a loop here? So let's take a look here. What you're going to notice is that I've got a little function here that I've called nameCheck. It's going to take in a name, and then it's going to return a Boolean based on whether or not the length is greater than 5. Now, you're going to notice that I've got the universal long-running operation blocker there, calling thread.sleep. Don't put that into production code, just a little tip from me to you there. And you're going to notice on thread sleep that we're just going to sleep for that half a second. So that's going to be how we're going to pause things. Now, what you're going to notice up at the very top here is that we're going to use for each. Now, I should mention that all collections in .NET built in have a for each method. It's kind of cool. that with for each, what I can then do is say, hey, look, for each item, call this method. It's sometimes a cleaner way than actually using the C# for each keyword. Now, the problem with calling either the for each keyword or that for each method is that it's a synchronous operation. So it's going to look at the first one, the second one, the third one, the fourth one, the fifth one. And in my case here, I've got 5 names. So if you do some real quick math, we're pausing for a half a second on 5 names, that's going to take 2.5 seconds to loop through everything. It's not really what I want. This is where parallel for each comes into play. That with parallel for each, what we're going to do is we're going to say, hey, for every single item in names, we want to call that function. So we're going to call name check, but it's going to do so in parallel. So it's going to grab all of those names and it's going to process them all in parallel. And it's actually going to spin up as many threads as it can, really 1 per core. So if you have 4 cores, it'll spin up 4 threads. If you've got 8 cores, it'll spin up 8 threads, and it will figure that out automatically. And so now, rather than taking that 2.5 seconds, if I have, let's say, 6 cores, so we could do everything at once, it would only take a half second because it's going to operate on each one in parallel. Okay, well, let's keep digging by taking a look at a real quick question. You have the following code. So you'll notice we've got a collection of items there. And then we're going to call our little where method here. Make sure, let's do that way. There's our little where. And then right here, we're calling off to method 1, whatever method 1 is. And then what you're going to notice is that we've got our little for each where we're going to display out the results. Okay. Now it tells us that for that method 1 here takes several seconds to complete. So method 1 is going to be our challenge here. We need to ensure that our code executes in the shortest amount of time possible. What should we do? And it gives us 4 little possibilities here. And so the first option is to convert that into a list of objects. Is that really going to help us? No. So we're going to get rid of that. The second one is going to say update line 3, and we're going to the end of line 3 add in this little as parallel. Or we could add it in at the beginning, or we could use that little as parallel on the for each loop. Interesting. All right, so what should we do here? We need to make sure that it executes in the shortest amount of time possible. We know that method 1 takes a little while. So we probably want this to go in parallel. We want this to go asynchronously. So based on that information, we know we want it to go as parallel. It's got to be BC or maybe D, but let's talk about D for a minute. D is actually going to update this line up here, line 4. Line 4 has nothing to do with method 1, so we can get rid of D. So now we're down to these 2. So now, what does as parallel do? Well, what as parallel is going to do is it's going to take a collection of items and make all operations on those items run in parallel. The catch is that we've got to convert the collection first before we start doing operations. So if we take a look at B and C, you're going to notice that we've got this at the end. So we've already called method 1, so that's not going to do us any good. So the only option that we're left with is going to be C. So make sure that you convert that as parallel first, and then we can go ahead and make that, that call. Another question. You have a method that accesses a database, so some long-running operation, using the following code. And you can see that right there. You need to ensure the original exception is thrown back to the caller. What code should you add to line 7? And so you'll notice that we've got 3 different variations on throw, and then we've got a return. Well, we can go ahead and get rid of, that return right away. There we go. We'll go ahead and get rid of that one right away. So now we're left with A, B, and C. Now, you'll notice that we need the original exception. Well, this is going to create a new one. Well, we clearly don't want that. So now it's down to A and B. So let's talk about the difference between throw and throw EX. What throw-ex is going to do is it's going to take that exception object and throw it right from here. But it's going to throw it as sort of a new exception. So the original exception is not what's going to actually get thrown. If we want to throw the original exception with the original stack trace, what we need is just the keyword throw. And so you're going to notice that the correct answer here is A. All right, let's talk a little bit about types. Now, I'm not going to get in and talk about the basic syntax of public, class, blah. But what I do want to take a look at, however, is constructors. And the reason that I want to take a look at constructors here is because this is one of those things that we often take for granted, but have a huge impact on how our code works. So up at the very top, what you're going to notice is that we've got just a basic classic class declaration. Boy, that was a little challenging for me to say. Let me try that one more time. What we've got up at the very top is a classic class declaration. Knew I could do it. Where you're going to notice that it's just simply public class default constructor. Every class needs a constructor. And so if you don't define one, the compiler is going to create one for you, and it will set all of the values inside of that class to 0, null, false. 0 for all number types, false for all Booleans, and then null for everything else. And that's a big thing, because you want to keep in mind that strings are classes. So with a default constructor, your string is going to be a null value. It's not going to be an empty string. Now, if you don't want somebody to create an instance of your class, maybe you want to give them a factory method, then what you can do is you can create a private constructor. And so you'll notice, there we go, my little private constructor. Now, once I do that, no default constructor is going to be created, but one other very big thing is that we're not going to be able to inherit from that class. And the reason for that is in order to inherit from a class and create that is a relationship, we need to be able to create an instance of that base class. With private, remember, private, only that class can call it. There wouldn't be a constructor that I'd be able to call. So if that's the only constructor, I'm not going to be able to inherit from that. Now you're also going to notice that we could create a custom constructor, and you see the syntax there. Big thing to keep in mind is that when you do that, no default constructor is created. So the only way to create an instance of this class is to pass in a name. Which also means that if we want to inherit from it, we need to explicitly call that base class constructor. Now, the signatures don't need to match. And by that, I mean that if I wanted to add in right here an additional parameter, maybe like an ID, I'd have the ability to do that. But I always have to call that base constructor because .NET isn't going to know how to do that automatically. Now, .NET also offers you generics. I love generics. That generics, in a nutshell, are data types, but stored inside of a variable. Now, everybody knows how to create, for example, a list and specify a generic. But I often see developers that haven't done it from the server side, if you will, haven't done it from the class creation side, which, by the way, if you haven't, you're really missing out on an awful lot of power. Take advantage of generics. In any event, what you're going to notice is I've got a little sample right here. And so I've got a little class here called class 1. And you're going to notice that I've specified a generic T1. So you're now going to be able to tell me what T1 is. So everywhere that I have T1, you're going to notice that I can use that just like a normal data type. But you're also going to notice that I get to constrain that data type. So I get to specify, hey, look, I want that to be an object. And I can also specify that I want that to have a default constructor, and that's what's going to allow that little bit of code right there to work. Because I indicated up top, hey, look, it has to be a class with a default constructor, or parameterless constructor, I should say. And then what you're also going to notice right here is that I'm going to say, hey, look, with method 2, or method 1 rather, I'm going to take in another type, another generic type. And so again, that can work just like a normal data type. So you'll notice we can say, all right, well, you're going to give me whatever that data type is. But again, I can constrain it, so I can say, hey, look, it has to implement iClonable. And so what that means is that I know that there's going to be a clone method there, so I can then call that, which is pretty powerful. All right, another question. You create a class using the following code. You add the following method to a class named class 2. So var class 1 equals new class 1. You need to ensure that class 1 functions correctly in the using statement. So which interface should we implement? So the basic question there is, all right, well, we want to be able to use a using statement. What's required to use a using statement? iClonable, iDisposable, iEquatable, iComparer, and the answer is going to be iDisposable, disposable, or, oops, it says A on the slide there. Trust me, it is in fact B, iDisposable. Now, here's the big thing. The big thing about that question is you are going to want to be familiar with the interfaces, the common interfaces in .NET. Now, you might be thinking, I don't want to memorize all of those interfaces, and I'm with you. I've got better things to do with my time as well. So, a little pro tip here is that all interfaces, and in fact, really everything that you see in an exam has to exist. So if you're seeing it there, you know that it has to exist. So if you're ever not sure, a good strategy, go with the one that makes the most sense. Go with the one that's the most logical. Okay. Another question. You have following code. You need to add string 1 to collection 1. What lines of code should you do or should you add? Choose all that apply, and each answer represents part of the solution. So we know we need at least 2 items here. All right, so we can update line 3 to be string 1 equals string 1 semicolon. Okay, so instead of it being var, we're just going to update that to string. There's the big change there. Update line 4 to be class 1 equals new class 1. Okay. At line 5, insert class 1 collection 1 equals new list of string 1. And then finally at line 6, go ahead and add in string 1. So let's talk about things real quick here. You're going to notice that both lines 3 and 4 are just trying to get rid of those var statements. It doesn't matter. It's not going to make an ounce of difference because .NET is going to be able to figure that out. So if you eliminated answers A and B immediately, the only 2 that are left are C and D, so those have got to be the right answer. And I'll give you a little hint, they are. But I want to go one step further with this. That, here's the thing. You're going to notice that class 1 does not have a constructor specified, which means that it has a default constructor, which means that everything is going to be set to 0, null, false. So collection 1 is going to be null, which would mean that if I just tried to call add without creating that brand new instance, it would fail. So that's why both C and D are needed there. All right. Let's talk a little bit about debugging, implementing security. Now, when it comes to encryption, the biggest thing that you want to know for the exam is the different types of encryption that are available. So for starters, we've got symmetric encryption. So it's reversible encryption, single key, and it works a little bit like this. You're going to notice that we've got a little bit of entry data, hello world, and we're going to convert that into some bit of ciphertext, And then we are going to be able to convert that back. So it's reversible encryption, one key. And you're going to notice that there's the namespace and a couple of very common algorithms that you can use. We also have asymmetric encryption, which is still reversible, but it's going to use two keys. One private, that only you have, and one public that everybody else has. And the way that this works is that one key is going to lock, and the other key is going to unlock. So once again, we've got our entry text, and that can be locked, for example, with our private key, convert it into that cipher, and then in order to get it back out, we would need to use the public key to do that. And again, there is the namespace, and down below is some of the common algorithms. Last but not least is hashing, where when we start with some bit of text, we're going to convert that into ciphertext, and we're never going to be able to get that back out. And then one more time, there's the namespace, and then there is some common algorithms. We've got an awful long time without doing a demo. Let's do a demo. Let's take a look at how we can control serialization in .NET. Now, by default, every class is automatically serializable. If we want to control that, the simplest way to do that is by using data contract on the class. And then we can identify our different data members, or even ignore one if we wanted to, and change how we want the output to work. So you're going to notice here that we've got first name and we've got last name. And when it's serialized, we're going to convert that to given name and surname respectively. Now down below, I've got my basic little demo here where we're going to use a memory stream. We're going to use a JSON serializer. And then when we want to use that serializer, we just simply say, hey, go ahead and write that out to the stream. Here's the object. And then for demo purposes, we're just going to go back to the beginning of the stream and then write that data out. And then one more time, we're going to go back to the beginning of the stream. And then we're actually going to read an object back in by using read object. And you'll notice that we do need to convert that. And there's my cast right there. So the end result is going to wind up being, when we run this, is that it's going to be given name and surname that will be written out to the screen. And then you'll notice that it will be able to deserialize the object. So if you do want control over how serialization, deserialization is going to work, that's how you could do it. You are going to notice, if you check out the objective domain, that writing out to the event log and tracing are both there. If you want to write out to the event log, there's the basic bit of code. Then we new up an instance of event log, indicate the source, which is going to be which event log we want to write it out to, and then we indicate the entry, which is going to have our message, the type, and then an associated ID or number. As far as tracing goes, if you want to configure that inside of app config, then what you're going to need is two main items. You're going to need a switch, which is going to indicate the level that you're going to want. So that could be verbose, information, warning, or error. And one big thing to keep in mind is that the more verbose ones, so verbose and information, for example, are also going to include the ones that are a little bit more critical, such as warning and our error. So if I specify verbose, that's going to be verbose, informational, warning, and error. So we need the switch, and we also need to indicate where we want to write that out to. In this case, it's going to be the console log, but you could actually write out to the event log. You could write out to an XML file as well, if you so desired. Now, when it comes time to actually then do tracing, what you're going to notice is that we need to new up our trace source, and you'll notice that that's going to match the name inside of the config file. You're going to notice that we can then write out to any individual listener that we want by calling to the collection of listeners, or if we just want to write out to all of them, then we can just simply use trace event. Now, what you're going to notice here is that with warning and verbose, that all that I have to do is just indicate the type. the way that it's going to know whether or not it should actually write out is based on the switch value here. So with us having this set to warning, the warning message would actually be written out, but the verbose message would not. If I change that value inside the config file to maybe verbose, then both the verbose and the warning message would get written out. Now, if you don't want to use the config file, you want to do that all programmatically, you could do that as well. You just simply need to new up a switch, and you need to add in a brand new listener, and that's exactly what we've got right here. And then you could go ahead and just go back and start using that trace event like we saw before. So you just have to go in and new all that up on your own. Okay. .NET also gives you the ability to control compilation. And the way that that's done is by using flags. So you'll notice that right up at the very top, we can define our flag. So you'll notice define demo flag. And then down below here, you're going to notice that we just simply check to see if that flag exists. Do you have a flag? And so if that flag has been defined, then all of this would wind up being compiled. If it wasn't there, then none of that would be compiled. You'll also notice that you could actually even control how the compilation is going to wind up working. You could add in a warning message right here, or you could even cause the entire thing to error out by calling error just like that. The last little thing that we want to take a look at is implementing data access. You'll notice the basic setup to read from a stream. So we set up our file name, we set up the buffer size, and then we loop through the buffer, or loop through the data by going one chunk or one buffer at a time. That every time that we call read, we need to indicate how much data we actually want back. Let's set up a link scenario here. So you're going to notice that I've got a couple of basic little classes here. I've got a category and a product. And you'll notice, of course, that we're going to set up a relationship between them. So you'll notice both of those items right there. And then you're going to notice that inside of my basic little program that I'm going to create a whole bunch of different items. So pizza, pasta, soda, water, ketchup, and mustard. So you can see all of that there. And then you're going to notice that I've got a basic little setup to go get all of the categories. So you're going to notice that our pizza is going to be food, as well as our pasta. Our soda and our water are going to be beverages, and then our condiments are going to be ketchup and mustard. Cool. And then down below, we're going to set up our two basic lists of categories and products, and then we're going to join them together. And you'll notice the syntax for join is that we're going to use on right here, just like we would in SQL. But unlike SQL, we're actually going to type out equals as opposed to using the normal equals operator. And what this is going to wind up giving us, there's the join result, is one table back, just like in SQL. But when you do grouping, it behaves a little bit differently. That in grouping, it's actually going to give us back two separate tables, or really one outer table, a parent table, that's going to have all of our groups, and then all of the children or the items inside of there. And so you'll notice that actually right here is that here is our little setup. So there's our little products. We're going to group them by category ID, and then we're going to have our group key and our products. And then you're going to notice that we'll loop through all of the groups, and then we'll loop through all of the products that are inside of there, so that our group is going to have the key and then the two items, the key, the two items, the key, and the two items. Another real quick question for you. You are creating an app that will process orders. You need to ensure that all orders are processed in the order in which they are received. All calls are handled in the order in which they are received. What collection type should you use? Hash table, dictionary, stack, and queue. So what we need to do is actually eliminate a couple. Both hash table and dictionary give us the ability to go find individual items. Stack and queue are going to dictate a specific order. the way that stack is going to work is last in, first out. This says they need to be processed in the order in which they are received. So we need queue, which is going to be a FIFO, or first in and first out. So there's a good smattering of some of the different topics that you're going to see on the exam, and hopefully we've helped kind of point you in the right direction. If you're looking for additional resources, a couple of great ones to check out. Again, Microsoft.com/learning. You're also going to notice that we do have the training guide. That's actually an app, and you can see that down at the very bottom. And then the one in the middle, and it's the one, of course, that's near and dear to my heart, which is Microsoft Virtual Academy. We've got a ton of great courses that you can check out there. In the meantime, thanks for tuning in, and good luck on the exam.